Hello. Welcome to the workshop on the challenges and promises of inferring emotion from images and video at CVPR 2020. My name is Alish Martinez, and I want to welcome you to this very exciting program that we have set up for you today. A few of us decided to organize this workshop because we strongly believe that there is a disconnect between what computer vision and other AI researchers think emotions are and how they are conveyed through facial expression and body pose, and what the actual science tells us. Take faces as an example. Undoubtedly, faces offer information that helps us navigate our social world, influence who we love, and determine who we trust or who we believe. But to what extent does an individual's face reveal the person's internal emotions? To what extent and how can we design computer vision systems to accurately interpret an emotion or intent from a raised eyebrow, a curled lip, or a narrowed eye? And to what degree are these visual cues influenced by body pose and context? Recent research shows that faces and body expressions alone are insufficient to perform a reverse inference of image to emotion, and that context, personal beliefs, and cultural norms must be accounted for. This workshop will present these limitations and examine several new courses of action to successfully interpret the emotion and intent of others. We have assembled a unique set of expert researchers to present the challenges and promises of inferring emotion from images and videos. We have four very exciting invited speakers that I will present very shortly. In addition, we have 3 additional papers that were peer-reviewed and selected from a very large number of submissions. I want to especially thank all the authors that submitted the work, and unfortunately, we only had a space for 3 of the very amazing papers that we received. Additionally, we also have 3 papers that correspond to the 3 winners of the EmotioNet challenge. Each of them will tell us the specific methods that they use to design their algorithms to outperform the state-of-the-art in facial expression analysis and specifically action unit recognition. I want to emphasize that facial expressions have been studied in detail in psychology, neuroscience, philosophy, and most recently, AI, and in particular, computer vision. Researchers generally agree that human emotions correspond to the execution of a number of computations by the the central nervous system. Some of these computations, sometimes, in some conditions, yield facial muscle movements, which are generally called action units, or AUs for short. For example, here we can see several action units that are typically seen in expressions that people call happiness, surprise, and fear. As an example, action unit 6, which raises the cheeks, correspond to a wrinkle in the eye that can be detected as a smile. AU 12 and 25 correspond to the open mouth smile. Hence, when these AUs are combined, we believe or think that people express happiness. But is that always the case? As we all know, there are many other factors that influence this. For one, we are very good liars. I can smile even though I'm not happy. And you know that I can smile and I may not be happy. On the other hand, not every time that I'm happy, I'm going to smile. Sometimes I've been happy for a whole day and I've not walked down the street smiling like the person in the picture for a whole day. In other words, not everyone who smiles is happy. Not everyone who is happy smiles. In addition to that, there are other problems that we have identified over the years. Look at this picture of the male character in the famous painting by Wood, This American Gothic. In this male character, people typically perceive a facial expression of sadness. This is understandable. This person looks sad to me too. But does he really look sad? Or is he actually sad? Well, if you look very closely, there are no action units active in this image. That is, there are no facial muscle articulations. All that happens is that this person has a very uncanny distance between brows and mouth, very large, and a very thin face. And we have shown in previous research in my lab that this is related to the interpretation of sadness in faces. You may actually be familiar with the expression, what a long face you have today, meaning how sad you look. But it has nothing to do with you being sad. This is just your bone structure has been designed in a way that correlates with how people voluntarily express sadness. And hence, many of us interpret this expression to be sad. If I, however, modify that image to have a wider face and a shorter distance between brows and mouth, now this person looks angry. Again, this person is not moving a single facial muscle, yet I interpret anger from his expression. This is an incorrect inverse inference, and there are many like this. Another factor that our research has identified in the past is that when, remember, we express an emotion, we experience rather an emotion, our central nervous system executes a number of computations, and some of these computations correspond to the release of hormones and other peptides. These hormones change the blood flow and blood composition. And because the face, as shown on the screen, is innervated with a huge number of blood vessels, then your face pulsates in color. We have actually demonstrated that in the same way that you can interpret some emotion categories, either correctly or incorrectly, from facial muscle articulations, you also interpret emotion categories from changes in color, again, correctly or incorrectly. I may be blushing because I just went out for a run, doesn't mean that I'm embarrassed about what you are saying. Yet, that's the most typical interpretation that people will make. Another problem that we have is that we tend to think that faces and faces alone actually convey all the information that we need. They are not only sufficient, but they are necessary. Well, consider these two images. The image on the left looks like that of an angry man. The image on the right of a very sad girl. But when you see them in context, these two expressions correspond to actually very happy expression. The man on the left actually just scored the goal. The girl on the right is probably looking at an idol or someone very famous that she really admires, and she's crying of happiness. They're both happy expressions. So we went from interpretation of a negative emotion to a positive emotion just because of context. Computer vision and AI systems do not include that information right now, and we must address this. The community must resolve this issue. We're very lucky today to have with us Lisa Feldman Barrett. Lisa, a very good friend of mine and an amazing researcher, has reshaped the way that we interpret and analyze emotions and the way we do research. I would highly, highly recommend her book. If you haven't read her book, How Emotions Are Made, please stop the video right now, buy it, and read it. This is a must-read book for everyone in the community. It challenges many of the things that were assumed to be true just because they were hypothesized many, many years ago. But recent research, as I have mentioned, and I briefly showed here, tells a different story. Her talk is a must-see talk today to understand how these challenges are going to influence AI and computer vision. We are also extremely fortunate to have another good friend of mine, Ralph Adolph. He is an amazing researcher that has done fundamental work in the interpretation or our understanding rather of emotions and how those are implemented in the brain and in biological neural networks. Ralph is a professor of psychology, neuroscience, and biology at Caltech, and he's also the director of the Caltech Brain Imaging Center. Both his research in psychology and neuroscience have transformed the way that we understand how emotions are produced and conveyed to others. Another good friend of ours, Racheal Jack, has very recently, in the last decade or so, revolutionized the interpretation of basic or so-called universal facial expressions. Her work combines a number of different disciplines to explain why culture and many other factors play a role in the interpretation and the production of facial expressions. I certainly, for one, look very forward to hearing her talk. Finally, we have Agata Laperdiza, who is an associate professor at Universitat Oberta de Catalunya and who works in computer vision and primarily in the scene understanding and affective computing. She's done amazing work on the interpretation of emotion through context. I think that her research is very timely, and she is a rising star in the community, and I look forward to also hearing from her and her new research. As I mentioned, this year's workshop also includes results of the EmotioNet Challenge, or the 2020 EmotioNet Challenge, I should say. We have included over 20 different action units. We have close to 100,000 images that have been manually annotated with these 20 plus action units. And teams were asked to train the system with weekly annotated data, manual annotated data, and then test it on an unseen sequestered data at a later time. We had many participants in each of the 3 phases of the challenge. And in the final phase, we had 3 winners. The top 2 winners actually got pretty much the same score. There was a tie for first place, but the first team just got slightly just ahead in the numbers of the second. So not a big difference, but I consider them the 2 top winners. But at any rate, Tomorrow Advancing Live actually got the first place. University of Magdeburg got the second place, and a coalition of 2 Chinese universities actually got the third place. I think Qianli Feng will actually talk a lot about this in his talk, so I really encourage you to look at this. And then each of the teams will present the work in the corresponding talks later on this afternoon. We have an exciting program, as I have mentioned. We're going to start with the talk by Lisa, followed by Rouse. We'll then do a short coffee break so that everyone can, just think about everything that has been discussed before we actually move to Racheal's talk. And then, technology permitting, we are going to try to have an online discussion between all of us. That's at 11:30 a.m. PST, Pacific Standard Time. So make sure to connect to the system at 11:30 to have a discussion with all the members of the community that can join. We're going to follow this by a 1-hour lunch break. After that, we're going to have Qianli's presentation of the summary of the EmotioNet Challenge, the results. He's going to go over all the results going back to 2017 to present, 2020. And then we're going to have short presentations of the first, second, and third place of the EmotioNet Challenge for this year, followed by another coffee break, followed by Agata's talk, another coffee break, and then the final 3 talks, which are the 3 peer-reviewed papers that we have selected from a large number of submissions. Well, this is it for me. I really hope that you enjoy the workshop. I really hope that you learn a lot of new research and advances that have been done in recent years in this area. I think this is a fantastic area to work on. I hope that you continue working on it, and I look forward to the discussion today. Thank you.